Okay, welcome back to PyraPOD. I'm glad to present the newest design for PyraTENT. This is PyraTENT, not ViviPod. Similar to ViviPod, but it's PyraTENT. This is the PyraTENT version 2. Yeah, the everything the same. The only difference we place a central hollow square column as a support, but also as a passage for the soap bubbles. Okay, so the soap generator, the bubble generator, will be placed at the lower portion, roughly in here. So you can install from the bottom and then insert it in, and then that's the soap bubble generator. And then everything rests, like hose, right, the wire, anything that you want to hide, and you can hide inside the column, make everything tidy, and that's it. And the top portion, similar to ViviPod, right? It's open but got a screen, right, on each surface. Simply a window screen, that's fine, because the point is to prevent the bubbles from sucking into the chimney. This is the chimney, right? The fan will be roughly here, and then everything's for hollow. So there's negative pressure in this portion, right? Then if there's no screen, then the soap bubble will be sucked in right away when it reaches to the edge, right? But if there is a screen, then it tend to give the surface tension, and then forcing the foam to go upward, right, until it filled entire cavity. And then there's no way to go but to go through the screen, right, being crushed, and then and then that's complete the circuit. So in this case, the soap bubbles, just like the ViviPod, will be produced from the bottom, right? But because this is a larger structure, the edge is 5 meter by 5 meter, and the height is 5.37, about 5, and a half. And then because this is a larger structure, and if you fill the entire structure just like the ViviPod, from the bottom and then from four sides, and then the bubbles basically expand upward, and then there you may tend to see this problem we call channeling, because this foam is not steady, right? It's a dynamic thing. It's chaotic state. And then if certain region has this more air passage happening, then that creates a channeling, and then then the air flow in the channel in that region will be faster, and then that means you got kind of a close to short circuit, but not exactly short circuit, right? But just tunneling. We can call it tunneling. And then that will make the filling not uniform. For that reason, we in this design we have a mechanism below the platform. Below the platform, it's hard to see here, but I like to show another shot, another scene that it basically a vertical cut, and so that section cut will reveal the bottom portion, right? So as you can see, we have the basically this mechanism is very simple. Just two columns, two round columns, one inside another. The inner one fitted has this portion because the water is roughly here. The water is slightly above, right? And then it's fitted with screen. See the dark area? This is the screen, but the outer column has a opening, has a slot of opening. Just this is the width, and the bottom is just one piece, right? It's just a opening, a window, wide open window that rotate, right? When that slot rotate to this section, what we see, and then that expose the screen, right? So for that reason, the bubble will be produced through the screen. So and then fill this section only, not others, because all the others are closed, right? Because that column has only one slot, one vertical slot, one vertical opening, right? And then you can manually rotate that, or automatic rotation that will control which section you want to fill, right? So in this way, we can fill one section only, So you fill one section at a time. When you have the total fill, then you switch, or the system can automatically rotate, and then try and fill the other one, right? And this way, you can fill any section on demand, right? Depending where you want to fill. So this way, we think it's better because that reduces the chance of channeling, but also give us the privilege to fill the section, fill one section at a time. Okay, so as you can see, the whole design, divide the space into 4 sections, right? We have dividers, see 4 wings. The 4 wings attached to the inner cover, and then when we install, we simply drop this in, and then use the edge to wrap around the outer arcs, right? The curvature, and wrap around and create a tension, and then that finished the inner cover installation. And then the outer one is just simply a cap, simply a hat. You just drop in and hold it everything. And so this way, the whole thing is very it's tensioned and looks nice. So because of the mechanism at the bottom, there's a slot rotate, right? When the slot facing this section, for example, in summertime, we won't only want the south side to be filled, right? So then we can simply rotate that slot, let it face south, and then the bubbles coming from there only. So that means bubble will coming out from this section, then expanding, rising, right, and fill the entire cavity, and then return through the chimney. Yeah. So then the circuit will be like this, right? But when in the summertime, you may want to fill the west side only after the sun, before sunset, right? Then mainly the sun coming from the west side. So then you can fill the west side, So anyway, in winter time, you always want to fill the north side, right, to retain the heat. And then at nighttime, we want all the 4 sections to be filled. But that could be filled, alternately, right? Just you fill one section at a time. I rotate, fill this section, and this section. So each section, the filling time could be somewhere around few minutes, basically, and then you simply rotate just in about 10 minutes. Then you can fill every section. So this gives us the choice, right? To fill one section at a time. So very nice. We like this design. Yeah, that's why I like to present this. The other thing is, as you can see, we have two designs. Actually, everything the same, and just the door are different. Here we use a mechanism to make solid door, but on the right hand side we have the door. Basically, it's a zipper door. Simply two doors, like a flap, the roll up thing. You just you unzip the zipper like this, and then you roll it up, right? And then you see bubble wall, right? And you simply walk through the bubble wall. There's a steps here in the middle. You can step on that and then just walk into the platform, right? Into the tent. And then afterward, you can even just close up the door, right? And then just doesn't affect the fitting, right? That's it. We didn't show a vertical screen on each side, and also a horizontal screen here. There should be a horizontal screen here. That's easily can be done. And then the purpose is to prevent the bubbles from falling down, right? As you walk through the bubbles, right? You just create a passage, like a man-shaped passage, and you walk through, and the screen will prevent the bubble from falling down. The screen on the side prevent the bubble from crushing toward you, and then that's it. As you can see, there's a fan and a duct, and the fan simply blow fresh air into the PyraTENT, give you the fresh air, and then there will be ventilation of inner air also through the on the side. Basically, it could be a double layer duct, right? The air blowing in, and then the inner air coming from the double layer cavity, right? And then there's heat exchange, right? There's automatic heat exchange as the air going in, and then the inner air going out. Yeah, very easily you can have something like that, and then this way you can recycle the heat. You don't lose the heat too much, right? So that's it. That's that. I think lastly, I just show you the soap reservoir. As you can see, the soap reservoir is basically buried in the ground, right? This way it prevent the soap liquid from freezing, right? Keep into maintain a unfrozen state during the winter time. And as you can see, the central tank is the area is much smaller than the entire PyraTENT. So this way give you more insulation through the top cover, right? Top shelter, and then from the soil around the soap reservoir, right? And when we make the soap reservoir, we can even fill the wall, like a foam structure, give some insulation, and that will give you more insulation property, right? And then we use the soap, the green container, the soap reservoir as a box, right, to contain everything, right? We can disassemble everything, the cover, the all the column, the metal, whatever. We can just fit everything in to this box, and then simply when someone want a kit like this, want a unit, and then we just simply ship this box to you, right? And that's why then that's pretty simple. Yeah. Anyway, here I see that it shows the line goes from the side. That's actually for the early version. Yeah. Since we have this central column, we can actually allow the line, all the lines, whatever, just go through the central column, right? Central column, and then that's it. And as you can see, there's this portion we could even easily place solar panels, right? Somewhere here, and then produce power, and then it could be self-powered, off-grid, because there's space to. So it's better to place the solar panels inside the tent, right? Outside the tent, you tend to get, in the winter time, get snow on the panel, right? But you place inside, there's no snow, and in a relative warm condition. So everything will be fine. Yeah. So the other thing is the 4 columns. I'm thinking that if we have a frame, a relative strong, frame, a curvature, arc tube, and then if that's strong enough, then we may make the connection horizontally, and then to the short column attached to the top edge of the soap reservoir, right? And then we may need, we can remove the 4 vertical columns, and then give you more space. Yeah. We'll leave that to the manufacturer, and then when they make everything, then they know the strengths. They need to choose what the material they use, right? And then figure that out. I'm sure they can. There's no problem. As you can see, the triangles everywhere, so that will make the whole structure very stable. So that's it. Hope you like it as we are liking it. Because we are glad that with a central column, and we can have one bubble generator, and then we can fill whatever section we want. So this is very nice. Yeah. I'm very, very excited. We hope that we can produce this tent quickly, and hopefully by the winter next year, you can have one like this. Even even hopefully during the summer and summertime, we can get this product rolled out. Yeah, great. Thank you. See you next time.